Hello and welcome to the ROHDE SCHWARZ 35 webcast series. My name is Matthias Weilhammer. I'm a product manager at ROHDE SCHWARZ, and as probably most of you, I'm also working from my home office right now, and so I would like to use the time to give you a brief introduction into the topic 5GNR base station conformance testing. So let's get started. Here's the agenda. I start with a quick introduction, and the main part of the presentation is on conducted conformance testing with the three important chapters for transmitter characteristic, receiver and performance characteristic. There's also a shorter part on radiated conformance testing, and at the end I will highlight where to find relevant application notes on this topic. So conformance measurements are defined by round 4 of 3GPP, though there's the 38104 which defines the general RF characteristic and minimum performance requirements of base station. And there is the 38141-1 and -2 series for conducted and radiated conformance testing. There are different base station types now in 38141. The base station type itself is declared by the vendor, and this defines then also the test method. So a base station for frequency range 1 can be either a conducted, a hybrid, or a OTA. Let's say the normal way is that the base station for FR1 is still measured in conducted, and for FR2 all the tests needs to be done over the air. So in order to get repeatable and comparable measurements, defined signals have to be used. So for all transmitter measurements, these are the so-called test models. The test models are defined for FR1, and there's another set of test models for FR2. They distinguish also by bandwidth, so depending on which bandwidth is supported by the base station. And in FR1 there are also different TDD and FDD test models. And for a certain kind of measurement, the base station needs to transmit the correct test model, and then the parameter is then measured by the measurement equipment. The same concept applies also in the uplink. So for the receiver measurements, the signal generator provides defined input signals, which are called reference measurement channels, and these FRCs are then used for both for the receiver characterization and for performance measurements. So also here for different measurements, different FRCs are defined. Here is a list for FR1, and in FR2 there's another set of FRCs. Okay, now let's come to the main part, which is the conducted conformance testing. So for conducted conformance testing, the latest released version of the spec is version 15.5 from March this year. And here I show a short abstract on important chapters. So in chapter 4.1, the allowed measurement uncertainties and test requirements are defined. 492 describes in detail the test models. Then the chapter 6, 7, and 8, which I will come to in a minute, in more detail. And in the annex, there's also information on the reference measurement channel or the system setups. Okay, so now let's come to the transmitter characteristic measurements. So here we see the setups for transmitter measurements. It's not too complicated. For most measurements, each RF port of the base station is directly connected to the measurement equipment, and the measurement equipment itself is usually a signal and spectrum analyzer with a 5GNR option in order to demodulate the signal. For some measurements like transmitter intermodulation, an additional generator is required for the interfering signal. And this is a complete list of all chapter 6 measurements, starting from the 6.2 base station output power to 6.7 transmitter intermodulation. And it shows where you get the information on the measured parameter, either in the 5GNR option or from the spectrum analyzer application. So let's have a quick demo on how to demodulate a 5GNR test model. We see the user interface of the FSW signal and spectrum analyzer, and in the spectrum mode the signal of a 5GNR test model is shown. So next step is that we go into the 5GNR option, and inside the 5GNR option you can select the signal description, and from here you can choose the test model which you would like to demodulate. So you select the name of the test model, and then you can apply additional filter functionality to find quickly your required test model. So in this case it's a 100 MHz TM31A test model, and after you have selected this you get an immediate sync, and you see this also by the constellation diagram of the 256 QAM is visible and the EBM is shown. Next topic is receiver characteristic measurements. This slide shows an example for intermodulation characteristics. So the measuring system setup, how it is shown in 38141. So for this measurement it is required to have a wanted signal plus a CW interferer and a modulated interferer, and on the right you see the corresponding setup with the signal generator SMW200A, which has 2 RF ports and multiple basebands. So this scenario can be generated out of one box. So you have a wanted signal from RF A, and the modulated plus the CW interferer can be generated on RFB. And here is this table shows a summary of all chapter 7 test cases from 7.2 receiver sensitivity level to 7.8 in-channel selectivity. And the normal way is that for receiver characteristics, the base station calculates the throughput on a wanted signal, and either the level is reduced of the wanted signal and a certain minimum throughput needs to be achieved, or for other test cases, additional interferer like AWGN or modulated interferer, or also out of band blocking signals with very high output power level are applied, and a certain minimum throughput needs to be achieved in order to pass a requirement. So we've seen in the slide before that most of the receiver test cases require multiple signals, so it could be quite time consuming to configure all the wanted and the interfering signal with correct frequency and amplitude offset. And that's why we implemented a feature called Test Case Wizard, which helps you to set up the signal generator according to the specification. So you just have to select the desired test case, and the instrument is then ready to go, and it supports you in for all transmitter, receiver, and performance test cases. And how this works can be shown in the next slide. So let's have a quick demo on the test case wizard. You see here the 5GNR user interface on the SMW200A, and there is also a button called Test Case Wizard. So once we click on that, there is a list of test cases which covers all the test cases from 38141 for chapter 6, 7 and 8. So in our example, let's choose the receiver intermodulation test case, and once we select it, there is already a graphical notification on which kind of signals have been applied. So here's the wanted, and these are the two interfering signals. And the next step is then that we choose the apply and also press here the OK button. And now the instrument gets configured. So let's go back to the block diagram menu, and in this menu you see that there are multiple basebands available to generate all these signals. So there's a baseband A for the wanted, and we can turn on the RF for the wanted signal, and there is a baseband B for the modulated interferer, plus the CW is also generated in the AWGN block. So let's also turn on the RF here. And of course it is very important to have the correct frequency offset of the signals and the correct level offset. And all this is for all this the test case wizard takes care. Though these are now the signals measured on a spectrum analyzer. I just offset both RF ports by additional 40 dB in order to have enough output power to see the signals on the spectrum analyzer. And in this certain test case, it should be proven that even with a mixing of the two interfering signals into the wanted band, that the base station still can handle it and achieve a certain throughput. The last part of the conformance measurement is the performance characteristic of the receiver. Performance measurements bring two additional challenges to the test setup. So first of all, additional fading needs to be applied to the input signal of the base station. And two test cases require also feedback from the base station into the tester, and then the output signal of the tester needs to be adapted in real time according to the hard feedback. And on the right, we see again the corresponding setup with the SMW. So from a hardware point of view, nothing has to be changed. It still can be tested with one vector signal generator. So the fading can be applied internally, and this instrument also accepts the feedback from the base station and modifies then the output signal on the RF in real time. This slide shows a summary of all Chapter 8 test cases. And these tests require that the signal is connected to multiple receiving antenna ports of the base station, and therefore, of course, the generator also needs to provide these additional RF ports. This can be achieved with these small extension units. So either 2 or even up to 6 of these extension units can be connected to the main unit, which then allows configuration of up to 8 RF ports, which is the maximum which is defined in the specification. So let's also here have a short demo. We are again in the test case wizard, and I've selected a certain Chapter 8 test case which requires a wanted signal with additional channel emulation and also additional AWGN. So after we hit the apply button and go to the block diagram, you can see that the wanted signal is generated in the baseband A, and in this example it is output to 2 RF ports to feed into the 2 receiving antennas of the base station. And AWGN and fading is not yet turned on, so we can see the clear signal of the wanted carrier. And here the AWGN has been turned on, and this is visible, of course, in the spectrum. So there is a certain bandwidth for the AWGN with certain signal to noise ratio. Next step is then also to apply the fading, and it is clearly visible that the level is fluctuating here due to the destructive and constructive overlay and this is the effect of the channel simulation. So also here I've captured a short video. So first of all the clear signal, then the AWGN is applied to the signal, and the last step is then to apply the additional channel emulation. The acceptable uncertainty of the test system is described in section 412, and here I only show an example on the required accuracy for transmitter tests, and also just a few parameters where I would like to demonstrate that the accuracy of the hardware is always much better to the required maximum test system uncertainty. So for instance, if you If you choose here the EVM, which has a requirement of ±1% uncertainty, and the EVM accuracy of an FSW is less than 0.37% specified. So in summary, you can be sure if you choose recommended hardware equipment, you will always fulfill the uncertainty requirements. Next topic is radiated conformance testing, and due to time I cannot go into the details here, so it is more a quick overview. All the radiated conformance tests are covered in the 38141-2, and also here the latest released version is 15.5 from March this year. The structure and the chapters are identical to the conducted version. Of course, there's always then the addition OTA and radiated for the different test setups and characteristic tests. So here we see the list for all the radiated transmitter characteristic tests, so chapter 6. The measurement and the test cases itself are the same like for conducted, but now of course all the measurement have to be done over the air. From a measurement equipment point of view, you choose the same 5GNR option to get to the results. Of course, the hardware itself needs to support the higher frequency range. The same is with the radiated receiver characteristic tests. So chapter 7. Also here you need again wanted signals and interfering signals. Now of course with different bandwidth and higher frequency ranges. And for the chapter 8, there's only one difference, that the number of receiving antennas for the base station is reduced to 2, whereas in the conducted case it is up to 8. As the connection between the measurement equipment and the DOT is an over-the-air transmission, all measurements need to be done in a wireless chamber. And here's just one slide to mention that RNS offers different kind of chambers, and it mainly depends on the aperture size and on the DOT frequency range, which chamber solution fits best for your device under test. So the different technologies which can be applied is to measure either in indirect far field, though this is called the CAT-R technology, or it could also be measured in the direct far field, which then of course increases also the chamber size. In addition to the chamber, also the accessories are required. Here's just one example of a wideband Vivaldi antenna from 4 to 87 gigahertz in order to provide all the necessary signals to the DOT or receive it from the DOT. Last topic, application notes. So for all 38141 tests, application notes have already been published. They cover the different chapters, transmitter, receiver, and performance tests. And in addition, there is also a test execution software available which enables remote operation. So this it provides several examples how to operate the instruments remotely for all the conformance tests. So these are the application notes for FR1, and there are also already 2 application notes for transmitter and receiver tests for FR2 available. So feel free to go to our website and download these helpful application notes. With my last slide, I would like to come to a summary. So the specification for 5G base station conformance testing is ready. For all conducted measurements, test setups are quite similar to what might be known from 4G times. For radiated conformance testing, the measurement characteristics are the same as for conducted, but of course the TNM equipment needs to support this higher frequency range, and the OTA testing adds additional complexity and uncertainty to the tests. For both cases, conducted and radiated, RNS offers a full portfolio to support you with your 5GNR base station conformance testing. So with this, I would like to close. If there are any additional questions, just go to the RNS website /5G or send me an email directly. Thanks for watching.